Hello everybody, I'm Marta from Colibri TD, which is a startup from France. And today I'm going to explain you what's our goal and what would like to do, which is mainly to democratize quantum computing, so to help companies to adopt quantum computing as soon as possible. So, one of the main problems of quantum computing right now is for sure the fact that it's really complicated and many people have already the expertise in their own domain, but they're not able to grow in expertise in quantum. So our role here would be really to help the end users that is really confused from, let's say, the landscape of quantum to understand what would be better for them. So this would mean to help the end user to understand which hardware would be the best, to which startup it should interact, if it needs some cooperation from academics, and so on and so forth. Of course, it would be us to take care of all these different aspects. But in concrete, sorry, doesn't change. Okay, because I have to go there. In concrete, this means that what we want to do is to build a platform in which we are going to take care of some use cases that, of course, are given by some clients. The platform is going to be as user-friendly as possible, and then it's up to us to put all the pieces of the puzzle together, which means that a customer will come to us, will ask for the solution for a use case that probably previously he was trying to tackle with a classic. It would be up to us to find the solution on the algorithm point of view and to select the best hardware for them, to select what we have in literature that can help us, that can help them, and put everything on a quantum algorithm framework. Right now, mainly I would say an hybrid algorithm, so classical and quantum. This in order to bring to the customers the highest advantage possible that doesn't have to be necessarily related to the time of a running, but can also be related, for example, to the precision or to the reduction of energy consumption of a certain simulation. So, our goal is to create a platform that gives quantum as a service. So, really, what we aim to do is to stay hardware agnostic, which means that we need to be able to deploy it in any kind of hardware that is going to be out there. First of all, because we don't know if there is going to be an hardware that is going to win the race, or if there are going to be many hardwares out there for many years. And moreover, because it can happen that a certain hardware is going to be more suitable for a certain application with respect to another. Our position is really end-user orienting, which means that we really want to help people that do not have a knowledge in quantum to enter this business as well, and use case oriented, which means that we aim to solve real use cases, from chemistry to material deformation, for example, to combustion, so really toward industry. And once again, we are going to combine all these things to give the best advantage for our customer. So, in order to do that, of course, as right now I only gave you an idea of what we aim to do, but I'm going to explain you now what's the first tool we are developing in order to achieve this goal. This tool is named internally right now multi-platform quantum programming, which is going to help us to deploy in any hardware. Right now, you know that there are many SDKs from Qiskit to Pennylane to MyQLM. You can name them, they are really several. And basically, each time you want to develop your algorithm, what you have to do is to write all over again your algorithm for a certain hardware, basically. So what we want to do with our multi-quantum programming platform is that, with our SDK, is that we want to write our algorithm only once and be able to deploy it in several hardwares. Right now, we are working on this project, and we can already say that we have MyQLM, which is actually QLM, which is a simulator from Atos. We have AWS, which means that we can deploy in Rigetti and IonQ, and Qiskit, which means, of course, that we can deploy in any IBM hardware, and probably after in any other hardware that is going to work with Qiskit indeed. This is going to be needed also to benchmark our algorithm. This way, with only one algorithm written, we can deploy it in several hardwares and understand which one is the best for a certain algorithm. Moreover, we would like to have in the future this tool as open source, or at least part of it. This way, we are going to give back to the community something, since we are let's say, taking a lot from literature and from academics, so it's our way to give something back to the community. So, as I was saying before, our business model is really use case oriented, and to be more concrete, until now we mainly worked on two use cases that are material deformation that arrived some years ago, starting from a challenge that is quite known in the quantum environment, that is the BMW challenge. And right now we are working on combustion. What's the tool behind all of this? Why I'm putting them together? Because mainly what we want to do is to tackle partial differential equations. So what this use case have in common, it's indeed the tool, the mathematical tool behind them. Not only we are working right now with material deformation and combustion is precisely a project that we have with the French government, but also in January we're going to start with another project that is still related to partial differential equation, but with the specific use case of computational fluid dynamics. So, of course, this would unlock a lot of other use cases, because partial differential equations are basically the way to model any real-life use case. So from automotive to chemistry, pharmaceutical, and so on and so forth, we can even imagine that even cancer growth, so the cell growth of a cancer, can be modeled by partial differential equation. So it's really, it would be really key to unlock such a subject. But so why this use case I mentioned? Because of course, one main objective for Colibri would be to do something concrete for humanity. So yes, it's nice to have quantum computing. It's nice even to use quantum computing from finance. But maybe we can do something better. We can do something that it's, let's say, have an higher meaning. So cancer, as you know, is a very, very spread disease. So it's basically the second leading cause of death. So cracking such a subject would be a turning point from the medical point of view. Right now, of course, this kind of simulation are not very used, because it's really complicated models and it's very heavy from the computational point of view. But even treatment can be modeled, and in principle, can be seen how a certain treatment could affect some kind of cells. And moreover, I talked to you before about computational fluid dynamics. We aim that because, of course, it's a very small step towards something bigger. In this case, it's climate modeling. Navier-Stokes equations are one of the base of for climate modeling. That also in this case right now it's very complicated, very heavy, and usually, of course, since it's climate related, even a simulation would be too heavy, and let's say that would be not on the good way, because carbon footprint of a certain simulation can be really high. So, of course, it must be worth to simulate such a thing. So this would, of course, help to see certain effects on the way we plan to change things. It's something could be really effective or not. So this would be really a very important topic we would like to explore. So the main goal of Colibri, as I told you, is to stay in front of the client, so to help people to understand quantum. And in order to do that, it's really key to be between research, so real research from labs and so on and so forth, but also with industrial. So we are really trying to make the bridge between academic and industry. And here we can see it, let's say, on the concrete, seeing what are our partnership. So right now we are really trying to stay in contact with all the academics people we had around us, because we are mainly all went out from a lab. And moreover, we are building a good network with hardware providers and simulator. And that's the last slide, to thank you all for the attention and to present you our team. And if you want to contact us or to connect with me, you have the 2 QR code that you can use. Thank you.
Thank you very much, Marta. What are your questions for Marta? Very interesting topic. Sorry.
Do you have any of the photonic platforms in there as well?
Not yet. We are currently in contact with Candela, but it's early stage. So right now it's not implemented or available through MQB.
Thanks.
More questions? I have actually a question. So you talked a bit about cancer and how we could maybe solve like partial differential equations to make some modulation and so on and so on. Have you already done something in that
Not
direction?
yet.
Or
We are trying to stay as generic as possible with partial differential equation, and this way, once we crack the subject, hopefully we can really apply it to, for example, cancer. Also because right now we don't have the expertise, because we are mainly physicists and computer scientists, and of course to go in that direction we would need or an help from, of course, someone external to the company, or to hire someone that has the kind of expertise we need. So from chemistry to pharmaceutical, that's something we don't have, unfortunately, right now.
but it will be really interesting to have a project like that. Thank you very much, Marta.